Hi guys, today we are going to talk about exponent rules. Okay, then we use exponential notation or exponents to write repeated multiplication. Example, um, 10 to the third power, that means, or it means 10 times 10 times 10. Okay, 10 times 10 is 100 times 10 is 1000. Okay, remember or important to clarify that 10 is the base, 3 is the exponent, and 1000, that is the answer, is the power, okay, or the answer. Second example, 8 cube, 8 square, or 8 to the second power, it means 8 times 8, and of course, it's going to be 64. Example number 3, 5 to the fourth power, it means 5 times 5 times 5 times 5, and if you multiply, 5 times 5 is 25, times 5 is 125, times 5 is 625. Now let's analyze some rules that we can apply if we are solving exercises with exponents. The product rule is the first one, and we have two cases. The first case said a to the n times a to the m. We can notice that in this case we have the same bases. A is the base in both of the numbers that are multiplying. Then in this case we have to keep the same base. Keep the same base and add the exponents. Example, 2 cubed times 2 to the fourth power. Keep the same base, in this case is 2, and add the exponents. 3 plus 4. 3 plus 4 is 7, then 2 to the seventh power is 2 times 2 times 2 times 2 times 2 times 2 times 2, and if you multiply these numbers, the answer is going to be 128. Case number 2. Case number 2, we have a multiplication, and now the bases are not equal. What is equal are the exponents. Then we have to multiply the bases and then apply the exponent. Example, 3 squared times 4 squared. 3 times 4. 3 times 4, of course, is 12, and 12 squared is 12 times 12, and it is 144. Quotient rules, really similar to the product rules. First case, we have a division because it's a quotient, and bases are equal. Exponents are different or the same, doesn't matter. But if the bases are equal, you have to keep the same base and subtract the exponent at the top minus the exponent at the bottom. It's always at that order. At the top, exponent at the top minus exponent at the bottom. Example, 2 to the fifth power divided by 2 to the third power. It's going to be 2 because the base is the same, to the 5 minus 3. In other words, 2 to the second power. 2 to the second power is 2 times 2 is equals to 4. A second case for quotient rule, it's a division, and now, as you can see, we don't have same bases, we have same exponents. In that case, very similar to the second case for product rule, you have to solve first the division and then apply the exponent. Then let's check the example. 4 to the third power divided by 2 to the third power. Then let's divide by the bases because the bases are different, but the exponents are equal. Then 4 divided by 2 is 2, and as the exponent is equal, then 2 to the third power. 2 to the third power is 2 times 2 times 2, that is 8. Power rules. We have 4 cases here. Then the first case is b to the n power to the m power. We have double power affecting b. Then it's in this case we have to multiply the exponents. Then it's going to be b to the n times m. Let's check the example. 2 to the third power to the second power. It's going to be 2 to the 3 times 2. In other words, 2 to the sixth power. And 2 to the sixth power, remember, is a repeated multiplication, then is 64. Second case, we have apparently one more time double power, but it's not double power. Okay, the exponent has its own exponent. Then it's b to the n to the m. Let's check the example. 2 to the 3 square. That means that we have to solve first 3 square. 3 square is 9. Then it's going to be 2 to the 9th power. Repeated multiplication, and the answer is going to be 512. Case number 3, we have a root with index m. Okay, then when we have a number that is affected by a root and by an exponent at the same time, that is going to be a fraction exponent. Okay, then the exponent is going to be at the top and the index of the root is going to be at the bottom. Okay, let's check the example. Square root of 2 to the 6th power. Then keep the same base, is 2, and now transform the square root and the exponent in a fraction, in an exponent fraction. Then it's going to be 2 to the 6th over 2. 6 over 2 is 3, then it's 2 to the 3rd power. 2 to the 3rd power is 8. For case for power rules is when we have a number to the fraction. The exponent is a fraction, but not any fraction. A fraction when the numerator is 1. Then in this case, always we have to transform into a root. A root where the index is going to be the denominator or the fraction, or the exponent fraction, and that's it. Then let's check the example. 8 to the 1 over 3, then 1 over 3 is the exponent, then 3 is at the bottom of the fraction, then it's going to be the index or the root, then it's going to be cube root of 8. What happens with 1? 1 is going to be the exponent of 8, but 8 to the 1 power is 8, then that's why it's not necessarily write that 1. A cube root of 8, of course, is 2. Now let's analyze these 3 more cases. Negative exponents. When we have negative exponent, we have to remember that the number has a 1 at the bottom in a fraction. And when you put the numbers the upside down, when you change the numbers, switch the numbers, then immediately the exponent change the sign. For example, 2 to the 3rd power. Then 2 has a number 1 at the bottom. If you change 1 and 2, if you switch 1 and 2, then immediately the exponent change the sign. Then it's going to be 1 over 2 to the 3rd power, or 1 over 8. 1 over 8 is 0.125. 0 rules. First case is b to the 0 is equals to 1. That means that any number to the 0 is going to be 1. Then 5 to the 0 is 1. 1 million to the 0 is 1. Okay? Any number to the 0 is 1, with just one exception, 0. 0 to the 0 is not 1. It's the only exception. Okay? Next. Second case for 0 rules is 0. When 0 is the base, doesn't matter what is the exponent, the answer is going to be always 0. Okay, that means that 0 to the 5 is 0, 0 to the 8 to the 20 is 0. 0 to any number is 0. There is just one recommendation or some exceptions, that is the exponent must be positive. In this case, it's not possible to solve if the n of the exponent is a negative number. 1 rules, the last rule. First case, b to the 1 is b. Its rule just say that any number to the 1 power is the same number. Then, for example, 5 to the 1 is 5, but 20 to the 1 is 20. And exactly for this example. And the second case is when the base is 1. 1 to the any exponent is always 1. Then, for example, 1 to the 5th power is 1, but 1 to the 20 is 1. 1 to the any exponent is going to be always 1. Okay, guys, thank you very much.